Have you ever stood under a truly dark sky, far from the glare of city lights, and felt a profound, unspoken connection to the universe? Have you ever felt as though the countless glittering eyes of distant suns were looking back at you, telling a story as old as time itself? That feeling, that sense of awe and belonging, is not an illusion. It is a recognition of your true home. Tonight, we embark on a journey together, not across miles, but across light years and millennia. We will peel back the veil of the night to reveal that the sky above us is not a static painting, but a living, breathing archive of cosmic history, a dynamic stage of creation and destruction, and a mirror reflecting our own deepest questions. So find a comfortable place, quiet your mind, and let's begin our voyage into the heart of the cosmos. Every single star you can see with your unaided eye is, in the grandest sense, a local. They are your neighbors in the sprawling, luminous metropolis we call the Milky Way galaxy. On the clearest, darkest night, you might be able to count a few thousand of these stellar neighbors, but this is like standing on a single street corner in a city of hundreds of billions and believing you've seen it all. The true population of our galactic home is a staggering number, perhaps as many as 400 billion stars, each a sun, many with their own families of planets. Think of it this way. If our sun were a single grain of sand, the Milky Way would be a beach stretching for miles. The stars we see are just the grains closest to our own, the ones we could pick up and examine. Beyond them lies the overwhelming, uncountable majority, a shimmering expanse of light and possibility. And what about those other galaxies? Objects like Andromeda, which on a perfect night appears as a faint, fuzzy patch of light, are entire cities unto themselves, located across an ocean of intergalactic space. We can't see its individual suns from this distance. Their collective light blurs into a single, ethereal glow. Seeing Andromeda is like standing on the coast of California and seeing the faint glow of Tokyo across the Pacific. It's a humbling reminder that our grand cosmic city is but one of countless island universes, and our view, as magnificent as it is merely a glimpse from our front porch into an infinitely larger community. Now, here is a concept that will forever change the way you look at the night sky. You're not seeing it as it is, but as it was. You are, quite literally, looking back in time. This isn't science fiction. It's a fundamental truth of our universe, dictated by the finite speed of light. Space is so incomprehensibly vast that even at a speed of 186,000 miles per second, light takes time to travel. The light from our moon takes a little over a second to reach us. The light from our sun takes 8 minutes. But the light from the nearest star system, Alpha Centauri, takes over 4 years. This means that when you look at Alpha Centauri tonight, you are seeing it as it was 4 years ago. Let's scale that up. The beautiful star Vega, which will one day be our North Star, is 25 light years away. The light you see from it tonight began its journey when many of you were just being born. The light from Betelgeuse, the red giant in Orion's shoulder, started its journey to your eyes over 600 years ago, around the time the Renaissance was just beginning in Europe. This has a staggering implication. Some of the stars twinkling in our sky may no longer exist. A massive star, 2,000 light years away, could have exploded in a supernova 1,000 years ago, and we would have no idea. For another 1,000 years, we would continue to see its steady light, a ghostly echo from a star that has already died. The night sky is not a live broadcast. It is a historical document, a collection of ancient photographs arriving at our doorstep every second. Each star is a postcard from the past, and the entire sky is a moving, dynamic archive of what once was. For millennia, sailors, explorers, and stargazers in the Northern Hemisphere have looked to one star as their ultimate anchor, Polaris, the North Star. It appears to hang motionless in the sky as the other stars dutifully circle around it, a symbol of constancy and unwavering guidance. But what if I told you that this celestial beacon is an imposter? Or, to be more precise, its role is only temporary. Our Earth is not a perfect spinner. It has a slow, subtle wobble on its axis, much like a spinning top as it begins to lose momentum. This wobble is called precession, and it traces a huge circle in the sky over a period of about 26,000 years. As the Earth's axis points to different parts of this circle, the star that aligns with our North Pole changes. Our current North Star, Polaris, is actually quite a good fit, but it's not perfect. It will get closest to true north in the year 2100, but to travel back in time 5,000 years to the age of the ancient Egyptians building the pyramids. And Polaris would have been just another star wandering in the northern skies. Their North Star was a much fainter star in the constellation Draco called Thuban. The pyramids were, in fact, built with internal shafts that aligned perfectly with Thuban, their celestial guide. And if we look to the future, about 12,000 years from now, our axis will point towards one of the brightest and most beautiful stars in the sky, Vega. Imagine a future civilization looking up at a brilliant blue-white North Star, a beacon far brighter than our current Polaris. This celestial dance reveals a profound truth. Even the things we perceive as most constant and eternal are part of a grand, slow, and ever-changing cosmic cycle. There are no fixed points, only patterns and cycles on a scale that dwarfs a human lifetime. Long before the invention of GPS, before the magnetic compass, humanity's first and most reliable map was written in the stars. For ancient peoples, the night sky was not just a source of wonder, it was a tool for survival. Imagine being a Polynesian navigator in a small outrigger canoe, thousands of miles from land, with nothing but the vast ocean in every direction. Your life and the lives of your people depended on your ability to read the celestial roadmap. You would have memorized the rising and setting points of hundreds of stars, the arcs of the constellations, and the position of the planets. These were your signposts, your compass points, your clock, and your calendar. In the featureless expanse of the Sahara Desert, nomadic tribes used the stars to orient their caravans, ensuring they could travel between oases without getting lost in the deadly heat of the day. They traveled by night, with the celestial patterns as their only guide. Celestial bodies became woven into the fabric of culture. The patterns in the sky were given names and stories, creating a rich tapestry of myth and legend that served a practical purpose. These stories were mnemonics, easy to remember tales that encoded vital navigational information. Polaris in the north and the Southern Cross in the south were not just constellations. They were humanity's first true north and true south, anchors in a world of uncertainty. The sky was the original shared human heritage, a universal language that guided our ancestors across every ocean and continent on Earth. On a truly dark night, one of the most breathtaking sights available to the human eye is the Milky Way itself, a luminous, cloudy band stretching across the entire arc of the sky. It looks like a celestial river, a spill of cosmic milk, which is where it gets its name. But what are we actually seeing? This breathtaking view is a matter of perspective. Our solar system is located within one of the spiral arms of our galaxy, about 2/3 of the way out from the galactic center. The Milky Way galaxy is shaped like a giant, flat disk, similar to a vinyl record or a frisbee, with a central bulge. When we look up at that hazy band of light, we are looking into the plane of that disk. Imagine you are a tiny speck of dust inside a pancake. If you look up or down, you see very little pancake. But if you look horizontally towards the center or the edge, you are looking through the entire width of the pancake. That's what's happening when we see the Milky Way. We are looking through the densest concentration of stars, gas, and interstellar dust in our galaxy. The billions upon billions of distant stars are so far away and so packed together from our vantage point that our eyes cannot resolve them individually. They simply blend together into that beautiful, ghostly river of light. This glowing path is both our home and our horizon. It's a powerful visual reminder that we are not just observing the universe from the outside, we are participants, living inside this immense structure, looking through the very heart of our cosmic city. Almost everyone has seen one. A sudden, brilliant streak of light dashing across the night sky, gone in an instant. We call them shooting stars and make a wish. But these magical displays have nothing to do with actual stars. Stars are massive, distant suns. These fleeting visitors are something much smaller and much closer. What we are witnessing is a meteor, a tiny fragment of cosmic dust or rock, often no larger than a grain of sand or a small pebble, entering Earth's atmosphere at incredible speeds. These particles, leftovers from the formation of our solar system or debris shed by comets and asteroids, travel at tens of thousands of miles per hour. As the tiny particle plows through our atmosphere, it compresses the air in front of it so intensely that the air itself heats up to thousands of degrees, causing it to glow. It's this glowing column of superheated air that we see as a fiery streak. The tiny particle is almost instantly vaporized by this intense heat. These meteors are a constant reminder that space is not empty. It is filled with the wandering debris of cosmic history. Each shooting star is a tiny piece of a comet or an asteroid, a messenger from the outer solar system, completing its final, fiery journey in our atmosphere, providing a momentary spectacle of celestial fireworks. There is a quiet, creeping tragedy happening in our modern world, one that is stealing a fundamental piece of the human experience from billions of people. For most of human history, a dark, star-filled sky was a universal sight, a source of inspiration, mythology, and science for everyone on Earth. But today, that view is becoming a rarity. In remote deserts, on high mountaintops, or in the middle of the ocean, the night sky is an almost overwhelming spectacle. The Milky Way is so bright, it can cast a faint shadow. The sky is crowded with thousands upon thousands of stars, a dense, glittering tapestry that feels close enough to touch. This is the sky our ancestors knew, but for anyone living in or near a city, this view has been almost completely erased. Light pollution, the collective glow of our streetlights, buildings, cars, and advertising creates a permanent, artificial haze in the atmosphere. This luminous fog acts like a curtain, drowning out all but the very brightest stars and planets. According to scientific models, more than 80% of the world's population now lives under light-polluted skies. For a third of humanity, the pollution is so bad that the Milky Way is completely invisible. This means that entire generations are growing up without ever seeing the true majesty of our own galaxy. They have been disconnected from a view that once defined our place in the cosmos. And spiritual loss, severing a connection to the universe that was once a birthright for all of humanity. When we look up at the familiar patterns of the constellations, Orion the hunter with his bright belt, the Big Dipper pointing to the North Star, the graceful curve of Scorpius, they feel ancient and eternal. We see the same patterns that the ancient Greeks and Babylonians saw. On the scale of a human lifetime, they are indeed fixed, but in the grand cosmic timeline, they are anything but. The stars in a constellation are not physically related. They are a celestial illusion of perspective. One star in the Big Dipper might be 70 light years away, while another is over 120 light years away. They just happen to lie in the same general direction from our point of view here on Earth, like looking through a forest and seeing two unrelated trees line up perfectly. Furthermore, every star in the galaxy is in constant motion, each on its own unique trajectory, orbiting the galactic center at hundreds of thousands of miles per hour. We don't perceive this motion because of their immense distance, just as a distant airplane seems to move slowly across the sky. But over vast stretches of time, these independent movements add up. If you could fast forward 50,000 years, the familiar shape of the Big Dipper would be warped and stretched into an unrecognizable pattern. The stars that form Orion's belt will have drifted apart. The night sky is not a static portrait. It is a slow, graceful, and colossal dance. The patterns we cherish today are temporary arrangements in a celestial ballet that has been unfolding for billions of years and will continue long after we are gone, a testament to the dynamic and ever-changing nature of our galaxy. For anyone who has spent their life in the northern hemisphere, traveling south of the equator is a disorienting and exhilarating celestial experience. The sky you've known your whole life is turned upside down. Familiar constellations like the Big Dipper and Cassiopeia sink below the northern horizon, never to be seen. Polaris, the anchor of the northern sky, is gone. In their place, an entirely new cast of celestial characters emerges. The most famous of these is the Southern Cross, or Crux, a small but brilliant constellation that has served as the Polaris of the South for explorers for centuries. You'll also see the bright stars Alpha and Beta Centauri, the closest star system to our own, but perhaps the most stunning treasures of the southern sky are two objects that look like detached, hazy clouds from the Milky Way. These are the Magellanic Clouds, and they are not clouds of gas or dust within our galaxy. They are two separate, small satellite galaxies orbiting our own Milky Way. Visible to the naked eye, these dwarf galaxies are our closest galactic neighbors, cosmic companions on our journey through the universe. Seeing them for the first time is a profound experience. It's a powerful, physical reminder that our perspective on Earth determines our window into the cosmos. The universe is a shared home, but the view from each room is different. It's a humbling realization that there is always more to see, more to discover, and that the universe is always larger and more wondrous than we can know from a single vantage point. On a dark, moonless night, if you know exactly where to look in the constellation of Andromeda, you might be able to spot a faint, elongated smudge of light. It's easy to miss. It looks like a tiny, wispy cloud. But that misty patch is the single most distant object the human eye can see without the aid of a telescope. It is the Andromeda Galaxy. That faint blur is an entire island universe, a majestic spiral galaxy, even larger than our own Milky Way. It is thought to contain as many as 1 trillion stars, more than double the number in our own galaxy, and it is located a staggering 2.5 million light years away. Let that number sink in. The light that is reaching your eye tonight from the Andromeda Galaxy began its journey across the void of intergalactic space 2.5 million years ago. At that time, modern humans, Homo sapiens, did not yet exist. Our early ancestors, like Homo habilis, were just beginning to walk the earth. The light from Andromeda is a true time capsule, a photon-based fossil from a time before human history. Staring at that ghostly smudge is one of the most humbling experiences imaginable. You are seeing a city of 1 trillion suns, but you are seeing it as it was in the distant past. It is a visible, tangible testament to the sheer, mind-boggling scale of the cosmos and our own fleeting moment within it. It's also a glimpse of our future. Andromeda and the Milky Way are on a collision course, destined to merge into a new, giant galaxy billions of years from now. If you look carefully at the stars, you'll notice they are not all the same color. Some, like Betelgeuse, have a distinct reddish hue. Others, like Rigel in the same constellation, shine with a brilliant blue-white light. Our own sun is a yellowish white. These colors are not random. They are a direct clue to a star's physical properties, telling a story of its life. A star's color is a direct indicator of its surface temperature. Just like a piece of metal heated in a forge, the color changes as it gets hotter. The coolest stars, with surface temperatures around 3,000 degrees Celsius, glow with a soft red light. Medium temperature stars, like our sun, around 6,000 degrees, shine yellow-white. The hottest and most massive stars in the universe blaze with a brilliant blue-white light, with surface temperatures soaring to 30,000 degrees or more. And why do stars twinkle? It is a common question with a simple answer that has nothing to do with the stars themselves. Stars do not actually flicker. They shine with a remarkably steady light. The twinkling effect is caused entirely by Earth's atmosphere. As a star's tiny point of light travels through the turbulent, swirling layers of air in our atmosphere, the light is bent and distorted, moment by moment. It's like looking at a coin at the bottom of a swimming pool, with ripples on the surface. The image of the coin shimmers and distorts. Planets, being much closer, appear as tiny disks rather than points of light, so their image is less easily distorted, which is why they tend to shine with a steadier light. The stars above are not just beautiful lights, they are the universe's factories. Deep within the cores of massive stars, unimaginably high pressures and temperatures create the conditions for nuclear fusion. This is the process where lighter elements, like hydrogen, are crushed together to form heavier elements, like helium. As massive stars age, they forge even heavier elements, carbon, oxygen, nitrogen, the very elements that form the basis of all known life. Every atom of carbon in your body, every atom of oxygen you breathe, was created inside a star that lived and died long before our sun was even born. We are, in the most literal sense, made of stardust. These stellar forges are the source of the raw materials necessary for building planets, and ultimately, for building us. Furthermore, our sun's solitary existence is something of a cosmic rarity. Many, if not most, stars in the galaxy are not alone. They exist in binary or even triple systems, gravitationally bound to one another, orbiting a common center of gravity. These stellar partnerships are more common than single stars like ours. Imagine living on a planet in such a system. You might have 2 or 3 suns in your sky, casting multiple shadows and creating days and nights of extraordinary complexity. These systems are a testament to the diverse and often bizarre arrangements the universe can create, reminding us that our own solar system, with its single, life-giving star, is just one of countless possibilities. Among the billions of stars in our galaxy, some are destined for a truly spectacular end. The most massive stars, many times larger and more luminous than our sun, live fast and die young. As they exhaust the fuel in their cores, they swell up into colossal red supergiants. A prime example is Betelgeuse, the bright red star marking the shoulder of Orion. Betelgeuse is so enormous that if it were placed where our sun is, it would swallow the orbits of Mercury, Venus, Earth, and Mars, and possibly even reach Jupiter. It is a celestial titan, living on borrowed time. At some point in the next 100,000 years, which is the blink of an eye in cosmic terms, Betelgeuse will run out of fuel entirely. Its core will collapse, and it will rebound in a cataclysmic explosion known as a supernova. This event will be one of the most brilliant spectacles ever witnessed from Earth. For weeks, the supernova could shine as brightly as the full moon. Visible even during the daytime, it will briefly outshine every other star in the sky combined. This explosive death is not just an act of destruction, it is an act of creation. The supernova will blast all those heavy elements forged in the star's core, the carbon, oxygen, and iron, out into the galaxy at incredible speeds. This enriched material will then mix with interstellar clouds of gas and dust, providing the seeds for new generations of stars, planets, and perhaps new life. We don't have to wait for Betelgeuse to explode to see the aftermath of such a cataclysm. In the constellation, Taurus lies a beautiful, glowing cloud of gas and dust known as the Crab Nebula. This is the expanding remnant of a supernova that was seen and recorded by astronomers in China, Japan, and the Middle East in the year 1054. They wrote of a guest star that suddenly appeared and was so bright it was visible during the day for over 3 weeks. Today, nearly 1,000 years later, we can see the wreckage of that explosion, a tangled, intricate web of filaments still expanding outwards into space. But at the very heart of this beautiful chaos lies something even more remarkable: the crushed, spinning core of the dead star. This object is a pulsar. A pulsar is a type of neutron star, an object so incredibly dense that a single teaspoon of its material would weigh billions of tons on Earth. It is the city-sized, collapsed core of the massive star that exploded. This particular pulsar spins on its axis 30 times a second, and as it does, It sweeps beams of radiation across space, like a cosmic lighthouse. Each time one of those beams sweeps past Earth, our radio telescopes detect a pulse. The Crab Nebula is a beautiful memorial to a star's death, powered by the bizarre, energetic corpse it left behind, a testament to the extreme physics that governs the universe. At the very center of our Milky Way, and at the heart of most other large galaxies, lurks the most mysterious and powerful object in the universe, a supermassive black hole. This is not the kind of black hole formed from a single star's collapse. This is a true monster, with a mass millions or even billions of times greater than our Sun. You cannot see a black hole directly. Its gravitational pull is so immense that nothing, not even light, can escape once it crosses the event horizon. It is the ultimate cosmic prison. So, how do we know it's there? We see its effects on everything around it. Astronomers have spent years tracking the orbits of stars very close to the center of our galaxy. What they found was astonishing. These stars are whipping around an apparently empty point in space at incredible speeds, millions of miles per hour. Their frantic, elliptical orbits can only be explained by the presence of a single, invisible object with the mass of 4 million suns, packed into an impossibly small space. These unseen giants are not just passive objects, they are the gravitational anchors that shape the galaxies around them. They are silent and invisible, yet their profound influence is written in the frantic dance of the stars that are caught in their inescapable grip, revealing their presence through the power they exert on their surroundings. Our Milky Way is just one of countless galaxies that populate the cosmos. When we look deep into space with powerful telescopes, we see them everywhere, island universes filled with billions of stars. They come in a beautiful variety of shapes and sizes, majestic spirals like our own, giant, featureless ellipticals, and chaotic, irregular shapes. These galaxies are not isolated. They are often gravitationally bound together in groups and clusters, and sometimes their mutual gravitational pull is so strong that it draws them together, leading to one of the most spectacular and creative events in the universe, a galactic collision. This is not a violent, instantaneous crash like a car wreck. It is a slow-motion merger that can last for hundreds of millions of years. As two galaxies pass through each other, individual stars rarely collide because the space between them is so vast, but the enormous clouds of gas and dust within them do collide, triggering a massive wave of star formation, a starburst that lights up the merging galaxies. Gravitational forces twist and stretch the original spiral arms into long, beautiful tidal tails. Eventually, over eons, the two galaxies will merge completely, settling into a new, larger, often elliptical galaxy. This cosmic dance of creation and renewal is how galaxies grow and evolve over billions of years, a slow and majestic process that shapes the very structure of our universe. Stars are social creatures. They are rarely born alone. Instead, they form together in large, gravitationally bound groups called star clusters, born from the collapse of the same giant cloud of gas and dust. We can see two main types of these stellar families in our sky. The first are open clusters, like the beautiful Pleiades, also known as the Seven Sisters. This is a young, loosely gathered group of hot, brilliant blue stars. Born only about 100 million years ago, they look like a glittering swarm of celestial diamonds against the black velvet of space. Over hundreds of millions of years, the gravitational bonds between these stars will weaken and they will slowly drift apart, each going its separate way through the galaxy. The second type are globular clusters. These are the ancient relics of our galaxy. They are massive, dense, spherical collections of hundreds of thousands, or even millions, of the oldest stars in the universe. Globular clusters, like Omega Centauri, are incredibly old, some nearly as old as the universe itself, dating back to the very dawn of our galaxy's formation. They are like cosmic retirement homes, silent, spherical cities of ancient suns orbiting the outskirts of the Milky Way, holding the secrets to the early history of our cosmic home. If you watch the sky on any given night, you might see a random meteor or two. But on certain nights of the year, the sky puts on a spectacular show, a meteor shower, with dozens or even hundreds of shooting stars an hour, all appearing to radiate from a single point in the sky. These predictable events, like the famous Perseids in August or the Geminids in December, are not random. They occur when Earth, in its orbit around the Sun, passes through the debris trail left behind by a comet. Comets are essentially dirty snowballs of ice, rock, and dust. As they get close to the Sun, the ice vaporizes, releasing a trail of dust and small particles along the comet's orbital path. Year after year, Earth plows through these same cosmic dust streams. When the tiny particles enter our atmosphere, they burn up as meteors, creating the beautiful spectacle of a meteor shower. The radiant point is an effect of perspective, similar to how snowflakes in a blizzard seem to fly at you from a single point ahead. Occasionally, a larger piece of debris, perhaps the size of a fist or a basketball, will enter the atmosphere. These create exceptionally bright meteors, known as fireballs or bolides. They can blaze brightly enough to cast shadows on the ground, and sometimes even explode with a sonic boom that can be heard for miles, a dramatic reminder of the constant stream of cosmic material our planet journeys through on its voyage around the Sun. No celestial object is more familiar to us than our own moon. It is our closest celestial companion, a constant presence in our sky that has shaped our culture, our calendars, and even our biology. The moon's powerful gravitational pull governs the ocean's tides, creating a rhythm of life for countless species on Earth. For millennia, its reliable cycle of phases, from new moon to full moon and back again, served as humanity's first and most universal calendar. But the moon's dance with the Earth and Sun occasionally produces some of the most awe-inspiring spectacles in nature. Eclipses. These occur when the Earth, Moon, and Sun align in a perfect, straight line. A lunar eclipse happens when the full moon passes directly through Earth's shadow. The Earth blocks the direct sunlight from reaching the moon, but some sunlight is filtered and bent through Earth's atmosphere, which strips away the blue light and casts a coppery red glow onto the lunar surface. This is why a total lunar eclipse is often called a blood moon. A solar eclipse is even more dramatic. This occurs when the new moon passes directly between the Sun and the Earth. The moon's shadow, a small spot of darkness only a couple of 100 miles wide, races across the surface of the Earth. If you are lucky enough to be in the path of totality, day will turn into an eerie twilight. The temperature drops, birds may stop singing, and the stars and planets become visible in the middle of the day. For a few precious minutes, you can see the sun's ethereal outer atmosphere, the corona shimmering in the darkness, a truly unforgettable sight. Among the twinkling points of light in the night sky, there are a few that behave differently. They don't twinkle as much, and over weeks and months, they seem to wander against the fixed background of the stars. These are the planets of our solar system, our cosmic siblings. The ancient Greeks called them planets, meaning wanderers. Each one has its own distinct personality. Venus, often called the evening star or morning star, is so incredibly bright that it is often the first celestial object to appear after sunset or the last to fade before sunrise. At its brightest, it can even cast faint shadows on Earth. Jupiter, the king of the planets, gleams with a brilliant, steady, golden white light. It is one of the brightest objects in the sky, and even a simple pair of binoculars is enough to reveal its four largest moons, the Galilean moons, appearing as tiny pinpricks of light orbiting the giant planet. And then there is Saturn. While its rings are not visible to the naked eye, even a small backyard telescope can reveal their magnificent, breathtaking structure. Seeing those rings for the first time, a perfect, delicate system hanging in the blackness of space, is a moment that can ignite a lifelong passion for astronomy. These wandering lights are not distant suns. They are worlds, both familiar and breathtakingly alien, part of our own solar system family. Occasionally, a new and temporary visitor will grace our skies, a celestial traveler from the cold, dark depths of the outer solar system. These are the comets. For most of their existence, they are inert, frozen chunks of ice and rock. But as their long, elliptical orbits bring them closer to the sun, they spring to life. The sun's heat begins to vaporize the ice, creating a glowing atmosphere around the comet's nucleus called a coma. The pressure of sunlight and the solar wind then pushes this gas and dust away from the comet, forming two distinct tails, a bright, curved dust tail and a fainter, straight ion tail. These tails can stretch for millions of miles and always point away from the sun, regardless of the comet's direction of travel. Some comets, like the famous Halley's Comet, are periodic, returning to our inner solar system on predictable schedules, linking generations of human observers who have watched their passage through the centuries. Historically, comets were often feared as omens of doom and disaster. Today, we understand them not as portents, but as precious scientific messengers. They are pristine relics from the time of our solar system's formation, 4.6 billion years ago. Their fleeting, ethereal beauty is a bridge connecting us to our own cosmic origins. In the far northern and southern regions of our planet, the night sky can erupt into a silent, breathtaking dance of light, the aurora. In the north, it's the aurora borealis, or northern lights. In the south, it's the aurora australis. Shimmering curtains of green, purple, pink, and red light ripple and wave across the sky in a display that is both otherworldly and deeply beautiful. This celestial light show is a direct connection between our planet and its star, the sun. The sun is constantly sending out a stream of charged particles called the solar wind. Most of these particles are deflected by Earth's magnetic field, but near the north and south poles, the magnetic field lines dip down towards the planet, funneling these particles into our upper atmosphere. When these high-energy particles from the sun collide with atoms and molecules of gas in our atmosphere, primarily oxygen and nitrogen, They excite those atoms, causing them to glow. The different colors are produced by different gases at different altitudes. Oxygen at high altitudes produces the rare red aurora, while at lower altitudes it glows a brilliant green. Nitrogen contributes hues of blue and deep purple. The aurora is our planet's magnetic field made visible, a silent, graceful dance of light that transforms the sun's invisible energy into a breathtaking celestial spectacle. For millennia, the only lights in the sky were natural ones. But in the last few decades, that has changed. The night sky has become busier, now home to thousands of human-made satellites silently gliding among the ancient stars. These new artificial constellations are a testament to our growing technological presence beyond Earth. One of the brightest and most easily spotted of these is the International Space Station, ISS. It often appears as a brilliant, fast-moving point of light, brighter than any star or planet, steadily cruising across the sky in just a few minutes. Watching it pass overhead is a powerful experience, a tangible reminder of humanity's continuous presence in orbit, a small outpost of life in the vast emptiness of space. But our presence extends far beyond what we can see from the ground. Space telescopes, like the Hubble and the James Webb Space Telescope, positioned above the distorting effects of our atmosphere, have revolutionized our understanding of the cosmos. They have peered deep into space and back in time, capturing stunning images of distant nebulae colliding galaxies and some of the very first stars to form after the Big Bang, revealing the universe in a level of detail and clarity that was once unimaginable. No matter where you point a telescope in the sky, in the seeming blackness between the stars, there is a faint, invisible glow. It is not light from any star or galaxy. It is the oldest light in the universe, an ancient echo of the moment of creation itself. This is the cosmic microwave background, CMB. For the first 380,000 years after the Big Bang, the universe was an incredibly hot, dense, opaque soup of particles and radiation. Light could not travel freely, but as the universe expanded and cooled, atoms began to form, and the universe suddenly became transparent. The light that was present at that moment was finally set free to travel across the cosmos. That is the light we see today as the CMB. Over the last 13.8 billion years, the expansion of the universe has stretched the wavelength of this ancient light, cooling it to a faint microwave glow just a few degrees above absolute zero. This remnant radiation fills all of space, coming at us from every direction. It is the baby picture of our universe, carrying with it the oldest story in the cosmos, the faint, residual afterglow of its own fiery birth. And so, our journey brings us back to where we started, standing under the night sky, but perhaps seeing it now with new eyes. Every glance upward is a journey into the deep, layered history of the universe. The soft light of the moon tells a story from a second ago. The light from Jupiter, a story from an hour ago. The light from the nearest stars reveals a history from a few years ago, while the faint, ghostly glow of the Andromeda Galaxy tells a story from a time before our species existed. And the invisible whisper of the cosmic microwave background tells the story of the universe itself in its very first moments of existence. The night sky is not a static canvas. It is a deep, layered archive of time, a constant reminder that we are part of an ancient and ongoing cosmic story. To look into its quiet darkness is to witness the echoes of creation, the lives and deaths of countless suns, and the silent, unfolding story of everything that has ever been or ever will be. The universe is not something that is just out there. You are a part of it. The iron in your blood, the calcium in your bones, the carbon in your DNA, all of it was forged in the heart of a long dead star. You are a living, breathing, thinking piece of the cosmos, capable of looking back out at your own origins and wondering. So here is my advice to you. First, just take a moment this week to go outside and look up. Put away your phone, step away from the screen, and just spend 5 minutes with the sky. Second, try to learn one new thing: a constellation, the name of a bright star, the phase of the moon. Make a small piece of the sky your own. And third, if you ever have the chance, travel somewhere truly dark, far away from city lights, and see the sky as it was meant to be seen. It will change your perspective on everything. I hope this journey tonight has sparked a sense of wonder in you, a curiosity to learn more, and a deeper appreciation for your place in this vast and beautiful universe. I have a few questions for you to think about. Which part of our cosmic story resonated with you the most? And how does understanding this immense scale of space and time change how you view your own life and the world around you? Please share your thoughts in the comments below. I would love to read them. Thank you for joining me on this voyage. If you enjoyed this journey and want to explore more of the wonders of our universe together, please consider subscribing to the channel and turning on notifications. It helps our community grow and ensures you won't miss our next adventure. Until next time.